Good morning. Thank you for coming so early after this nice evening yesterday. As a person living near the Alps, I was always confronted even early with first of all, with the advances and retreats of glaciers, and secondly also with the different moving societies, say during the migration period around 600 AD or even earlier, the Celts, and therefore you got quite very interested for cold periods during the Holocene. Let me start with the facts first. A few facts, and these facts are mainly dealing with the millennial scale, climate change or fluctuations during the Holocene. And let us start with the classical subdivision of the Holocene as it is written down in many different papers based on the chronozones. We have three periods. First of all, the pre-boreal and boreal chronozones with a high northern hemisphere summer insolation compared to today, and the large continental ice sheets starting to melt. Then we have a second period between about 9,005 to 6,000 year BP with the Atlantic chronozones, also called the Holocene climate optimum, or based on the work first by Denton and Carlen, the hypsio altithermal, and maybe then later on the neoglacial, from 5 to 6,000 year BP to pre-industrial. That's now based on the neoglacial, the classical expression by Denton Carlen, looking at the subboreal and subatlantic chronozones, and the low values of the northern hemisphere summer insolation were typical for this period, and the sea ice increased during this time, and we had a selection of many. We had many glaciers growing during this period. Maybe it makes sense to look at the more dynamical way onto these periods of the Holocene. If you think in a dynamical way, we have to think about the melting ice caps or ice sheets. We've already seen this figure in another talk. You have in this paper by Carlsen et al., you have this representation of the Laurentide ice sheet at about 9 kilo-year BP, which was really big at this time and was just in the stage of melting. We're having different curves of sea level change. There's just one of these from the Northern Sea by Bern, worked out in a long study before 2003. And as you can see, the big melt of the ice sheets was about finished around 6,000 years BP, and then it's clear there were still melting areas, but we only had a small change of the sea level of a few meters. What we do not know exactly is, and what would be very important, is now the distribution of Arctic sea ice over time, and I think that's one of the very important topics we have to deal with in the future. We have to know more about the Arctic sea ice. Okay, if we're just looking in a more dynamical way to these different periods, I think we have to look at the orbital forcing, which was, as I told you before, decreasing during the Holocene in the northern hemisphere. That's 65 and 15 degrees north for summer, and it was increasing in the southern hemisphere. And the interesting thing is that this is quite a large amount, even if you're dividing it into periods of about 1,000 years. It's even a remarkable amount. Altogether, over the 10,000 years, it's almost 40 watts per square meter. What we are actually working on, and we have to work on really strongly, is volcanic forcing. This is out of our paper, one time series with a blue record from Greenland and read a record from Antarctica by Tom Crowley, and it's just showing the volcanic activity in the tropics, the strong tropical volcanic explosions during the last 6,000 years. It gives us the impression that we had quite a high frequency during the last 1,000 years. I think that's important. Even Caspar Ammann tells me that it's not so safe to follow this data set, but I think it's important to work on this stuff. And this is just based on a new reconstruction by Bern, which were based on 10 beryllium, which was calibrated now in the last month together with Klaus Fröhlich. And I think we're getting now a nice data set over the Holocene out of Bern. You see there are negative peaks even around 6,000 BP, and there is the remarkable negative peak just during the migration period Pessimum at 600 AD, and there is a series again of negative peaks also during the last 1,000 years. These are all the Wolf-Spörer, Maunder, Dalton minima. And then this is just a representation of the CO2 just to show the changes with the greenhouse gases. If we divide the Holocene again into different periods, we could tell we had the first period till about 7,000 BP. It was rather cool. We had the large northern hemisphere ice caps melting, but quite a strong solar insolation in the northern hemisphere. Then we had the second phase with a warm Holocene climate optimum between about 7,000 and say 4,200, and finally the well-known neoglacial cooling period with the glacier advances, and then the final period with the warming. And we can even ask, based on this figure, whether we would now be in a position of a little ice age still, if we would not have the anthropogenic climate change. I think that's one of the options we have to think about, also doing modeling over the Holocene or even over the last 1,000 years. Let me now come to a series of data and look at an overview. This figure was already shown by Peck. It's out of our review paper. And if you're looking at this series, showing more the thermal regimes by the red color, the humidity or humidity regime or water cycles by the blue color, and then the bond cycles with the green color. We can just start in the northern hemisphere. As we have seen before, there was a strong decrease of the orbital forcing in summer, and we can see that in several data sets based on delta 18O or even on pollen, we can see the decrease of temperature in the far northern hemisphere. If you are looking at the humidity regime or the water cycle, we have the well-known time series here around Latin America, showing a decrease of precipitation, mainly based, if you are looking at the series of these papers, mainly based of the ITC set movement. And we have also this decrease here. It has been discussed yesterday by Allegra Legrand, and we can even ask us whether it was not the decreasing monsoon or even these changes in the hydrological cycle. If we are looking then to other areas, it's also important, besides the Arctic sea ice, to have much more data in the tropics, especially in the Pacific, because of the whole dynamics within the Pacific warm pool. And I think this decrease of temperature here is only one example, and we all know that it's very difficult to tell something about the Antarctica. We know that we had a decreasing temperature in the eastern Antarctic area, but the situation in Antarctica is complex. And finally, many papers based on this data set with the bond cycles over the 6,000 years. We had 5 bond cycles in total. Jared Bond defined 9 cycles over the Holocene. If we are looking at some modeling work, we have this new paper by Carlsen et al. Showing, due mainly to the decreasing solar insolation in the northern hemisphere, 9 kiloyear BP minus pre-industrial, and we can distinguish the warming mainly in the northern hemisphere continental areas, with the cool, still low temperatures here in the area of the Laurentide ice sheet at 9K, and we can see that we had lower temperatures in here, and this is here representing the delta 18O precip. This is mainly a temperature effect, and we have again this thermal regime represented here. If we are switching to a precip result, this precip result is not showing 9,000 years, it's just 6,000 years minus pre-industrial. And again, we're having again the warm conditions in the northern continental areas and cooler conditions in these areas. And if you're looking at precipitation, you can see that there was a stronger precipitation at this time in the monsoon areas, say here in Africa, Asia, and even South America. Let us come now to the mysteries. I called it the mysteries. They are not all mysteries, but they are really open questions. If you are looking at the cycles, if we believe in cycles, I had a long discussion with Carl Wunsch once, and we had a long discussions whether we believe in cycles and whether we believe in processes just being behind these cycles. Then rapid changes, and there is also this question of the spatial extension of the coal relapses during the Holocene, and the question is also, did we have typical modes? Let us first start with a series of glacier look at glacier advances. It's just a figure taken together within IPCC, mainly organized by Olga Solomina. And what you see here is over the last 6,000 years, advances in these directions and the retreats of some large glaciers in the world, just from the far north, from the Arctic area to the southern hemisphere. And we don't have many long time series in the southern hemisphere, and I think that's also an issue we have to work on in the future. If we are looking to the northern hemisphere, we can see that we had mainly, if we are looking over the Holocene, we had mainly growing glaciers since the Holocene optimum, and we had several remarkable advances, even those who were early, even described by Denton and Carlin. And then if we are looking to the southern hemisphere, there is only one example here from the Western Cordillera in South America. It's rather showing a decreasing stage of the advancing glaciers, but this has to be questioned because we don't have a lot of data. At least in the northern hemisphere, we're having a series of advances which are quite detected quite well based on moraines, dendrochronology, and 14C analysis. And what we can see is mainly, there were mainly 4 very remarkable advances which were partly at the same time in different areas, say the so-called Little Ice Age, then the migration period pessimum around 600 AD, the 2800 BP event, which is also known, especially in Europe, as the tree-ring downturn, and then the 4200 event. If we are looking at this figure, showing the Bond cycles, I think these papers by Bond in 1997 and 2001 made quite a career later on, because many started to believe in Bond cycles, even in very remote areas of the world. And the hope of Jared, I remember when I had a walk with him at the south coast of Iceland once, was really to find a common process behind the whole bunch of Holocene cycles. You can see the definition here. A prominent feature of the North Atlantic's Holocene climate is a series of shifts in ocean surface hydrography, during which drift ice and cooler surface waters in the Nordic and Labrador seas were repeatedly advected southward and eastward, each time penetrating deep into the warmer strands of the subpolar circulation. And many looked at their data series and started to think, it's just a direct correlation with the Bond cycle, and started to think about different processes like solar activity fluctuations, like volcanic forcing, thermohaline circulation fluctuations, and so on. I think Bond's idea to show these cycles was a good one. It has to be questioned whether these cycles can to be really correlated with many phenomena all around the world. As you know, the Gerard Bond defined a 1,470-year cycle based on his spectral analysis. And today, based on the whole bunch of papers in our review papers, we screened about 400 papers over the Holocene. And if you're going through these papers, you're rather thinking that we really had some cold events, at least with a certain synchronicity in the North Atlantic, northeastern US, Northern African, and even Asian area. But if we are looking at these cycles, we are having the impression that these, and especially the 8.2K event, was mainly due to meltwater flux from the northern ice sheet. And if you're looking at the more modern time, we're having again these 4 cycles, Little Ice Age, migration period, 2800, 4200 event. I think these were more due to other factors, and it has to be questions what the role, especially of solar activity and volcanic forcing was, and we have to take in account other factors like thermohaline fluctuations. The question is, what happened in between? We don't know enough, as I mentioned it before, about Arctic sea ice, and I think the Arctic sea ice played a major role in the between when we had the transition from the strong insolation in summer in the northern hemisphere to the weak insolation in the present. What we did was just a screening of different papers, doing spectral analysis and looking at significant spectral peaks at the 90% level in different areas from south to north. And if you're looking at different papers and you're just looking at the spectral peaks, and we also did an additional analysis that the open circles in here, you can find a certain group, a certain small group around 1,500 years, but it's clear because of the availability of the time series, there are more short cycles in here, but it's not very significant. If you're looking at time series all around the Holocene, it's interesting that in each time series we have strong steps. And the question is also whether these steps were at the same time, and we had synchronicity, and we can just work out a certain theory and then do modeling just during these phases of large changes. This is just based on pollen analysis in North America, or the Hodel data set of Lake Chichanchayab in Mexico. It shows another step at another time. What we started to do now is to do, together with the mathematicians of our university, a statistical analysis based on all available time series over 10,000 years in the Holocene, which have a high resolution below 50 years. And we started also to do some filtering in order to get about the same spectra, what is not really possible. But if you're then taking the most significant time series and you're doing change point analysis, you can really find the steps in these different time series. This is just an example for West Pacific, and if you're then looking at the frequency over time, in the West Pacific you just find a peak around 8,200 years. If you're doing the same for the whole globe, it's very interesting that the peak is around 6,000 years. it's clear for me we have to get much more data. It's only some tens of data sets we have here. And we're now trying to get the same amount of data sets for each region and looking at the whole frequency at the regional scale. If you are screening, for example, literature about the Little Ice Age, and I'm now concentrating to finish at the Little Ice Age, you can then look at the different areas, again, from the northern Arctic area to Antarctica, and you can just take all the time series in the papers and look whether it was cooler or milder during the Little Ice Age, or whether it was dry or rather wet during the Little Ice Age. We don't have enough data to get a real comprehensive picture all around the world, but we can see that at least we had cooler and warmer periods in several areas from the Arctic area even to the southern hemisphere. Even the data availability is not big enough in the southern hemisphere. But at least we can see that we had two rather warmer period in between, even during the Little Ice Age, two milder periods around just before 1500 and just before 1800. That means the 15th and the 18th century. If you're looking at this figure with the modeling results of the Northern Hemisphere in the IPCC report, it's quite interesting that we're also able to figure out two periods with rather higher temperatures during this period. And if you're looking at the forcing, we can even see that the solar forcing was just on average or even a little higher. And most remarkable, there was no volcanic forcing, strong tropical volcanic forcing during this period. And I think much more work has to be done, much more modeling work looking at these different forcing. And again, I'm asking the question, would we be in the stage still in the stage of the Little Ice Age if we would not have this strong anthropogenic forcing? Finally, I was just drawing a cartoon to come to the conclusions. It's just showing the idea or the question about modes. And this figure was based on a screening of all the papers we have from the Middle Holocene or even the early Holocene around 9,000 years BP. If you're looking at these papers, you have the impression that at least most of the paper are representing a rather positive North Atlantic oscillation state and a weak ENSO activity. They're also showing that we have a positive correlation between the North Atlantic oscillation and the Indian summer monsoon, which is based on some papers negatively correlated with the East Asian summer monsoon and the Australian summer monsoon. I would not like to tell anything about sea surface temperature because that's a very difficult issue and we have also to work on that. But I think this whole idea of correlating these different modes and look what was happening in the models will be a very important topic in our work in the future. And we've to think about, first of all, what was the role of the thermohaline circulation in the whole business? What was the role of the atmospheric part? Was there an important wave train, for example, between the Indian Ocean and Europe? And I think the limits between these different regions along this line or along this line, the areas just being between the meridional North Atlantic system and the zonal Pacific system, these areas in the limit of these two systems might be very important for our field work and for our modeling work in the future. So let me come to my conclusions. At the millennial scale, the summertime cooling of the Northern Hemisphere led to a sudden ITCC set shift, a weakening of the Northern Hemisphere monsoon systems and lower SSTs in the North Atlantic area. At the decadal to multi-century scale, evidence for quasi-periodic fluctuations or oscillations exist, they were likely synchronous in the North Atlantic area. Some cold relapses, e.g. the 8.2 K event or the Little Ice Age, were probably global phenomena. Several processes are postulated, but no single process or theory might be responsible. Examples might be the meltwater flux in case of the 8.2 K event, high volcanic and low solar activity during the Little Ice Age. In any case, the growth and retreat of Arctic sea ice and the dynamics of the meridional overturning circulation might have played an important role. And if you are interested in more details, you can look at this review paper which was published last year in Quarterly Science Reviews. Thank you for your attention.
Thank you very much, Heinz. Other questions? Come on, you should have been waken up by now. Pierre. Pierre, wait for the microphone.
In your summary of modes, you haven't taken into consideration all the polar oscillation, like the Arctic oscillation and the southern, the Antarctic oscillation. Especially if you want to reconstruct sea ice, I guess these needs to be taken into account, right?
I clearly agree with that. I think the change of the orbital forcing between the southern and the northern hemisphere, mainly in summer when the amounts of insolation were really high, is very important. And I think one of the important dynamical aspects we have to deal with is to look at the polar laws and the dynamic of the polar laws over the Arctic area and the Antarctic area in case of decreasing solar insolation in a certain polar area, say Arctic or Antarctica. And I think we have also seen some posters dealing with the decreasing insolation and then the changing dynamics within the Arctic or Antarctic area, or say Arctic oscillation or Antarctic oscillation. And I think these studies are very important, and we need much more field work also to look at the representation of the westerlies, say in the Australasian, in Australia and New Zealand and South America, and the dynamics of the westerlies in the northern hemisphere.
More questions?
Heinz, you posed this question, whether without anthropogenic forcing we would still be in the Little Ice Age. Can you give us an answer, or at least your opinion?
Yeah, it's very, for me, personally, it's very different to give a clear answer, because we can imagine, first of all, if you're just thinking, we're just subscribing, or we're just taking the state of the last or the last years between 1350 AD and 1860 AD for the future. But then we had this, we had this warming just prior to 1900 AD, which is also a question. There are different processes described behind this warming. I just had a discussion with Leonard Bengtson 2 weeks ago, and then we could also think about long-term fluctuations in the whole ocean system, and then we could think that even this influence would be responsible to get to a warmer stage. But personally, I'm convinced that it is important maybe to do modeling work and in order to estimate what would happen without any anthropogenic forcing, and there is no reason to think that it is not possible that we would stay in this state.
Any further question?
Pierre is active this morning.
just maybe a comment about this interglacial period or future. Are we still in a cooling period? I've been hearing André Berger projections for the future, and he said, if I recall correctly, that normally only with the orbital forcing we would be in a long interglacial for the next 20,000 years.
Yes, but what makes me to be a little afraid, we had a discussion about 2 months ago with Jörg Bern and my friend Thomas Stocker in the Oeschger Center, and then Jörg Bern was showing us that not only the Schwabe cycle is now running into the negative part, it's also the Gleisberg cycle, the 90-year cycle. And if it's coinciding, you know, when we're getting into the negative part of the Schwabe cycle, of the Gleisberg cycle, and we're rather getting now in a negative North Atlantic oscillation stage. We even realized it the last few years, because the winters got got cooler and we got more snow, which is not the typical example for a clear negative NAO. But even if we are jumping into the negative part of the Schwabe cycle, of the Gleisberg cycle, and at the same time looking at the most important mode of the North Atlantic, we're jumping into the negative mode of the North Atlantic oscillation. Then I said to Tom Stocker, you will have a lot of work in your IPCC team to explain that to the open public.
Okay, thank you.